So welcome everyone. We have Jari, Collin from Telia today. So I will not blah too much, but little bit different topics than previously. So we are focusing specifically for the industry of 5G. So Jari, floor's yours.
Thank you, Petri. And good afternoon, everybody. And really nice to be here. I think it was several years ago when I was last time here in this course, but this is very, very exciting. So as Petri mentioned, my role in Telia Finland is the CTO, Chief Technology Officer, but I also have a role in Aalto University. I'm here as adjunct professor and the computer science department. So every now and then I give lectures, and mainly my role at Aalto is to support the research programs and being involved in those whenever it's useful for me and the others to join that. But today we are going to discuss about industrial 5G. So 5G mobile technology obviously, but dedicated for the industry sector now, or focusing on the industry use cases. And as you all know, this is a very hot topic at the moment in many industries because 5G can bring reliable integrated platform for industries to manage the wireless communications and also integrating the data platforms into the communications more tightly than before technologies. We are going to discuss about the real-time data-driven use cases. And when I say real-time, that's really important for the 5G era because we are talking about few milliseconds or tens of milliseconds. That is a big difference compared to the 4G. And I can explain in the use cases then what it is allowing. One note I want to make in the beginning is that when we are talking about communications technology, it's utmost important that the communication is reliable. As you understand, it's almost similar to electricity nowadays. So if there is some kind of hiccup or some kind of quality problem, immediately it becomes visible to the users and lots of applications can shut down or disturbance at least. And that is extremely important for industry sector. When talking about industrial 5G, the quality reliability is probably the most important characteristics of the communications. So that's shortly what I'm going to say today. And please feel free to interrupt anytime. So it doesn't matter if you have a question, just raise your hand and ask a question, and we can have a chat. Few words about Telia. So I come from Telia Finland, but obviously Telia Group has also other countries. Basically, we are focusing on the Nordics and the Baltics region. The biggest country obviously is Sweden, but also Norway, Finland are very sizable. Then we have operations in the Estonia, Lithuania, and we have a joint company in Latvia as well. Denmark, Telia Denmark is actually in the middle of changes because the mobile business has been sold out and there is a carve-out project ongoing. But basically the setup is, as I said, Nordics and Baltics. In Finland, we are obviously big player in the society, and we have roots in Finland already 150 years or so, and we have customers more than 4.5 million subscriptions if we combine all the technologies together. We are working in the mobile, we are working in the fixed, and we have lots of IT services as well, and data center in Helsinki area, big modern data center services. And we are investing in Finland roughly 200 million per year, and that has been ballpark throughout the years and probably will continue on the same level in the future as well. So really sizable investment program. Now I think before we go into the details of 5G, maybe this explains a bit the history and introduces you to the latest of the 5G So as you can see, this wireless technology is nothing new. Basically, the first generation, 0 generation, was already in the beginning of 70s. Probably some of you remember ARP technology. How many remember that? There are a few. Actually the first generation NMT, dedicated for the Nordic countries. That's also the reason why the Nordic has been forerunner in the mobile technology, because the NMT was technology that was standardized in the Nordics already in 80s. And that has been there. Then I would say that the biggest change happened when the GSM, the second generation, started. And as you can see, we are still working with the second generation technology. We have GSM networks up and running, and we don't even have a plan how long are we going to continue on that. So there are discussions ongoing with the Finnish governmental services and authorities that how long that technology should continue. So we are talking about even close to 40-year-old technology soon. So that's the life cycle of GSM. Just imagine how long. Then we started the third generation UMTS technology, roughly in the late 90s or so. The networks were open in the beginning of 2000 or so, but that wasn't that successful compared to the GSM. There were lots of hypes or lots of promises for the third generation, but it turned out to be not that big, let's say, improvement compared to the second generation. And that technology is there, but we are actually ramping the technology down at the moment. We have a plan that the third generation technology will be ramped down by end of the next year latest. But the ramp down is already ongoing. We do it region by region. And that is also the case with other operators in Finland. So Elisa and DNA are doing the same. And then what was successful, I would say, from the very beginning is this fourth generation technology, 4G. Basically, most of you probably use 4G actively at the moment. And the 4G technology enabled the mobile apps. Basically, the social media, some, was boosted by fourth generation mobile technology. And more people are being using different mobile services. And that has been because of the 4G. So that is a successful technology and continues. Nobody knows yet for how many years to come. But now the 5G is the new one. And actually the 5G technology started in Finland 2019. And we started that technology worldwide with the so-called non-standalone 5G. So basically it means that we have 5G base stations, but the core system is based on the 4G technology. And that, about a year ago, we started to implement the 5G standalone technology, which means that the core technology is also 5G. So basically we can say that we are still in the early phases of 5G because the core of the 5G is just about to start, and there will be lots of new services when we start utilizing the standalone technology more widely. Currently, Telia has a standalone technology available. We are using it very much in our private network cases for B2B customers, but we are also having 5G standalone used for the fixed wireless access, dedicated fixed wireless access connections. And we are learning all the time what kind of new features and enablements that offers. But most of the traffic still goes through the 4G core system. And of course, the frequencies are important. So which frequencies are we using in different technologies? For the 5G, we are using 3.5 gigahertz frequency. And then we have a lower frequency, 700 megahertz also available. That enables the wider coverage in the areas. And then also we have a 26 gigahertz frequency available, but that is only a hotspot for very dedicated use cases at the moment. So actually nobody has started to actively construct the 26 gigahertz frequencies yet, but it will come sooner or later, I would assume. And then, of course, we are waiting for the 6G. I know at Aalto University, many researchers are already focusing on the 6G. That is coming. And 6G and metaverse and all this virtual reality, that will change the game again. But coming back to the 5G, I would say the biggest benefit for the 5G comes first for the industries, because it allows low latency services, very dedicated slides services for different user groups. So I just wanted to show you this graph so that you understand that this is a very systematic, persistent development that we are working on in the mobile technology. And Finland has been and still is the forerunner in many mobile applications. That's good to keep in mind. We are number one in terms of the mobile usage. I mean, how many gigabytes per user we are using in the country. So that's number one in Finland. Now, what is then different between 4G and 5G? There are many improvement areas. As you can see in this graph, there are the main highlights. Of course, the capacity is important, the speed in terms of the users. But what I would say even more important is the latency part, the low latency, because that enables the automation, robotics, and these kind of use cases that are extremely important for processes, production, operations. And that is something what I personally feel that probably the biggest benefit compared to the earlier technologies. Of course, we can see energy improvements. We have some studies already done regarding that and so on, but the latency probably is the biggest single benefit. Now we come to the industry part. So as you know, there has been lots of debate on the fourth industrial revolution, and industrial internet, already introduced maybe 10 years back, has been the, let's say, the title that many research has been studying in terms of the industry use cases. And now when industrial internet applications are getting more common, and when the 5G comes and becomes available, that opens new ways of working, and that enables these use cases, what I've been sort of studying now lately, together with the colleagues of Aalto and Nokia and Telia. And industrial internet is basically IoT, Internet of Things, but the viewpoint is from the enterprise. It's not the consumer viewpoint, it's like how could you start making more productivity or increase your revenue by introducing new services with this industrial internet. Now, if we think about what does it mean in practice and the use cases, well, this is a good example, this car. Lots of digital services already embedded into the cars, as you all know. There are different kinds of services. Not all of them are in real time, but basically the sensors that are being integrated to the cars, they can provide real-time information. Just wanted to take an example on the applications that many of us are having. You can see in real time what's happening in your car. You know the location, you know the speed, you know the tire pressure, etc. So that kind of service is already available. And when new technologies with the 5G come into the traffic and transport, that enables even more real-time type of applications. And probably the use cases you have been hearing that cars without a driver or some kind of automated cars. They are getting more and more common. I don't believe that will happen in the near future in the traffic, but in certain restricted areas like industry, parks or harbors, etc., that's already taking place. And one of the use cases we are going to have today is the mining. And you can see from a video how the mine trucks and loaders are being managed from control center. The actual movement happens 1 kilometer down underground. So very sophisticated use cases. Okay, that's about the car industry and lots of new innovations taking place as we speak. And also the changes in the electricity cars and so on, that's even more, let's say, accelerating this development. Another more traditional industry in Finland, forest industry, which also one of the use cases we have had. There are lots of things that you can do more productively when you have these digital services in real time integrated together. And for instance, there are use cases where you are able to basically somewhere in the control center you can manage the uploading of the wood from the trains or trucks. It's more safely, it's more accurate, and it's more convenient, obviously, for the workers. So those kind of situations are already taking place. But these are only a couple of examples. But what is actually happening is that this data sharing that will boost these new cloud-based services all over. And when we are talking about few milliseconds, that's really a real-time applications we are going to see. And what is important to note is that everything is basically down to the data. So the data is the enabler for this development. So this is a picture from our Telia Helsinki data center, which is located in Pitäjänmäki. And actually in that location, we have different connections for the mobile networks, for the fixed networks, and the data center itself. So we can do the real-time analytics and cloud-based services in that location. So you don't need to go always to a big hyperscalers in order to do some data analytics. You can do it locally here in a close proximity to the users. And actually, when we're talking about 5G, the mobile edge computing is becoming more and more common, basically meaning that the computing takes place closer to the users. You don't need to do the computing in different big data centers in Europe or USA, but you can, let's say, distribute the computing in the mobile network. And this kind of computing closer to the users then enables these lower latency and even more sophisticated energy solutions. That has been also one of the research topics we have been doing lately. But the keyword is and as I said, real time means few milliseconds or a couple of tens of milliseconds. So if we are talking about 1 minute data, it's already rubbish in this industrial setting. So you need to have a real-time data in order you can really automate things. You can start predicting what will happen. And these kind of machine learning solutions integrated to this that opens new opportunities. So that's shortly an introduction to the topic itself. Now, if we stop for a while, do you have any questions regarding this? What kind of opportunities this 5G enables? How many of you are using 5G SIMs already today? Okay, roughly 20%. What is the main difference if you compare to the previous ones?
Energy consumption.
Okay. And you are interested in that, obviously.
I use a lot.
Are you interested in the energy efficiency in your?
Well, it would be cool, yeah.
Yeah.
It seems better that fast.
Yeah. How about the others?
It's more speed for the end user.
Yes, exactly. I would say that for consumers, the speed, increased speed level, that's probably the biggest value at the moment. What else?
This is different, but you mentioned that you have 5G standalone systems.
Yes.
But isn't 4G standard basically a special case of 5G? I mean, like, the 5G standard kind of includes 4G as well, and the frequency ranges, was it 700 megahertz and 3.5 gigs? I think those are also 4G frequency.
Well, you can basically, for instance, use 4G for the 700 megahertz for the 4G. So you can use different frequency areas for different technology generation. That's possible. But what I mean by standalone 5G, it means that you have the radio, i.e. the base station, and you have the core system, 5G technology. Most of the use cases we have at the moment, or most of the users, like probably all of you, are using mobile handsets so that it has a connection to the 5G base station, but the signal goes to the 4G core system, so this old core system. And this standalone means that the core is replaced from 4G to the 5G. And that enables new kinds of services in the future. And that was the reason why I said that we are only seeing the first phases of the 5G at the moment, although technology has been available. But the standalone is the new thing that is coming.
I was just wondering because I don't know if these are the frequency bands, like if you are using basically a frequency range which is included in 4G already, is this a marketing term to say that it's now 5G, or is it?
No.
Because isn't 5G actually, okay, you have like the low band and stuff like that, but, well, okay, it's weird because 5G has very like wide frequency range up to 10 gigahertz, but
the frequency is one aspect. It's like what kind of radio frequencies you are using. You can swap the frequencies to different technologies if you want. But the standard frequency for 5G in Western Europe has been agreed. It's 3.5 gigahertz. But in practice, you could utilize the frequency for other purposes as well. So for instance, what we are doing currently when we are ramping down 3G technology, we use the frequencies that we are using for 3G, we are moving to 4G and even to 5G. So the frequency is only one aspect of the system. But the core, I mean the computing and the core system, where every service has been prepared and built, that's the core of the technology. And now the standalone 5G means that the core is 5G. And when we are talking about 5G technology, it's good to remind everybody that it's a cloud native by nature. So it's a cloud technology, whereas 4G core is not cloud.
Yeah, you are probably right. I'm just thinking about, I do circuit design or hardware, so I'm thinking about that perspective. But okay, I get the like, operator side. Yeah, thank you.
Yeah, okay, good. Good questions, good comments. Anybody else? Okay, let's move on. I jump into the theory for a while. You probably have seen lots of books from Michael Porter. One of his articles he introduced 2014 was the smart connected products. They transform competition, and that is actually taking place as we speak in this digital transformation. The basic idea in this article, which I recommend that you take a look into, is that although if you have very, let's say, traditional industry, for instance, the agriculture, and you have a tractor in the future, the tractor is not only the machine that somebody drives and collects or harvests the food there, but it's actually part of the bigger system. And this technology enables that you can start optimizing not only how the trucks are moving in the field, but also optimizing when to do the harvesting, how to integrate different production and resources into the whole system. This is a very good article. I really recommend that you take a look into that. So now continuing on that, we basically made a research a couple of years ago. We started this research where we wanted to understand that how the 5G technology enables more speed, or how to accelerate the digital transformation in different industry sectors. So how to leverage 5G in order to accelerate the transformation. And that kind of study, we did it together with many industry sectors. We basically had 5 different industry sectors. We have mining industry, and Sandvik was representing mining industry. We had forest industry, Metsä Group representing that one. We had lift, or I would say construction industry, where Kone was the company. We had telecom, and Telia was there. And then we had oil and gas industry, so Neste were there. And what we did in this research, we wanted to understand the use cases for the 5G and how they accelerate the digital transformation in different industries. And that has been now studied 2 years, and it's now over. And we are finalizing the research results, and we are publishing a book on that. I can show you in the end of that. But the basic idea there was to go through different use cases, how 5G can boost the digital transformation in different industries. And if I sort of now recap the different sectors, so now starting with the mining industry, as you all understand, the mining environment is totally different than traditional industry because all the activities happens underground. So the transformation challenge was that how you can improve the efficiency and especially safety in the mining industry by utilizing the 5G there. And basically, it means that you can control the machines and different trucks and loaders underground from on-ground control center. You don't need to send people there in dangerous locations underground, but you can manage the drilling and collection of the rocks and moving the rocks without going there. And you utilize 5G technology in that. And I have a short video on that soon. So that was one of the use cases. And Sandvik was the case company, and they wanted to understand that what is the benefit from 5G versus the Wi-Fi technology, because most of the mines are currently working with the Wi-Fi technology. So we did some measurements on the different performance elements and so on. That was the use case we were studying, and I have a video soon on one of the big mines in Finland, how everything is done using the 5G. The second one was this forest industry. It's construction there, so it's a Kone case, and in the Kone case, the situation was that they wanted to understand that how could they start building the data platform for construction project already when the construction build-out has been started. As you probably understand, the first thing in the building is always the elevator tunnel or that. And in these kind of use cases, the lift or elevator is being used during the construction phase already. So when the first floor is done and the second floor construction starts, the lift is being used there to lift the people and machines and so on. And using the 5G, they were able to start building the real-time data sharing between the stakeholders in the construction area. So they were using cameras, they were using AI solutions from the cloud, and they were able to optimize the use of the material flow and people flow in the construction area. That was the second use case. The third use case was this telecom, and that was really much on the energy efficiency. And we did very thorough analysis that what is the energy consumptions 4G versus 5G. And the summary of the results, that's very interesting. There is a clear threshold. So more subscribers you have, actually more energy efficient that will come. So basically there is a clear logic, and I would say even big message to the consumer markets that if you choose for 5G subscription like you, it actually enables lower use of energy, which is good for the environment and less consumption. It's a big difference when the amount of users in 5G increases. It's a big difference in the electricity consumption. That was one of the use cases we studied. Forest industry, there were actually several use cases we wanted to do and trial with Metsä Group. They wanted to learn first that how they could improve the productivity by using video analytics and remote control mechanism similar to what the mining industry is doing. There were good learnings on that. They were even trying one of the robot in a mill area, robot moving around and checking different measurements in the mill area. That was Robot France, it was named. And then the third one was utilizing the so-called machine vision, so that the machine were able to identify different dangerous situations. For instance, when you were uploading wood from the trains, and if there was a wood coming down, everything is automated, by the way, so nobody is going there. But if there is a wood going down, that machine vision immediately understand that there is a risk that the process will stop, and then somebody needs to start digging into that and fix the problem there. And then the oil and gas, that was the use case. We wanted to understand what the drones can do in the refinery area. Refinery area, as you understand, in, for instance, Porvoo, here close to Helsinki, it's a huge geographical area. And every day there is certain routines that needs to be checks that there is no problems or so on. And now idea is that drones can do some of the inspections so that you don't need to send a man there and check in, but drones can do it automatically. And some measurements as well. So those were the use cases. And in the book we are now publishing, those use cases will be explained more in detail. But what I want to show you now is the use case from the mining industry. And let's hope that technology works now. Before we jump into the video, this is a gold mine in Lapland in Kittilä. The company called Agnico Eagle, it's a Canadian company. They own the mine, but they have mines all over the world. But this is the first mine where they have a 5G network up and running. So it's a 5G standalone, so core and radios. It's a private network. It's owned by the customer, and they are using it there. And as you understand, the network is underground. It goes even 1 kilometer underground, and there are tunnels more than, if I recall rightly, more than 160 kilometers or so. So really huge area. And the installation of the private network is sizable. It's similar to the small city in Finland in terms of the number of base stations. So really big installation. And they have made a video. I want to show you this video because they use it as a public reference. And this is actually good showcase for the other mines worldwide, because there are lots of challenging tasks in the mines. You can understand it's a hazard area. There are lots of, let's say, people safety related topics. They are talking all the time. There are lots of opportunities to improve the productivity by utilizing remote vehicles and so on. So therefore I want to show you this video now. Let's see. Okay. It's only sound, so doesn't matter. That was a scientific vehicle. Unmanned vehicles there, as you can see. And they are in the control center. So that was the video. So now I won't touch anymore. So any ideas? Just imagine if that is taking place already underground. What could we do in different industries already today on ground? And why is the mining industry so interested in building huge network underground? Safety, that's number one actually.
Reliability, I think, is the one. And I suppose when I visited Sandvik about a year ago, and we were talking about this, the communication activities and safety aspects as well, and they just mentioned that every available technology is in use currently simultaneously. Yes. Just for safety and security and reliability reasons. Yes. And for example, there are different kind of radars, line of sight measurement technologies for safety reasons, but I think this is one of the additions that kind of increases the opportunity or potential to actually make things even better than before. Yeah.
So Sandvik is actually producing and manufacturing these mining technology, these vehicles, the loaders, the drillers, or drilling machines, or however they are called. And Sandvik, in this research that I was referring to, Sandvik wanted to test the benefits of 5G versus the old legacy technology, as you said. And additional mines, there are all kinds of different communication technologies. So that's an environment where you just need to sort of understand that you cannot put a new technology just there. You have to really adjust it to the environment.
From one of the first slides you had the car included. So, and then you have the application for Mercedes there. So I have a Volkswagen. When you think this Volkswagen or VW, you can actually talk with Mercedes directly without any other activities. So when we go from cars to traffic safety, yes. So the cars can actually in real time talk to each other, warn about the slippery conditions and so forth. So I think that is what are the biggest kind of hindrances or bottlenecks why these new applications haven't actually raised up their head yet. I think the technology is there, the principles are there, but we haven't seen these kind of applications or solutions that much yet. Is it about the data sharing challenges, Not about the legal aspects.
I would say technology probably is not the bottleneck, but maybe it's more like how you share the data between different companies, and when there is a driver, the user, there is a GDPR requirements you have to consider all the time. So the data ownership, the data privacy topics are probably the main reasons. But
As well.
yeah.
Because in this data ecosystems, there are different roles. Some vendors are offering better data for the others to use, and how they can make money with their business model. So that's one of the questions. So how you can actually create new kind of ways of doing business with data.
As an offline comment, as a former scientific advisory board member of one of these manufacturers, Jari is completely right. It's less of technology. There are some technological questions, but it's less of technology. But putting it very bluntly, it is that, is it worth it? So the number of accidents on private cars have been dramatically lowered. And of course, we shouldn't put a money value for the human life. But still, there's a question that all of these kind of all cars talking to each other, it's not very clear that if there's enough added value for all the trouble combined then with all the legal problems which it generates, because once you introduce in a car industry the technology, you also take the legal responsibility what it is doing. And then the final thing, which is very challenging, what we engineers tend, let's say electrical engineers or computer scientists tend to forget, is the sheer power of the legacy technology. So we can put all kind of things for the Mercedes 500 or Audi A8, but when there is 250 million cars around, which don't even have an ABS brakes in, the question is if the one in the 10 million car has this fancy technology, is it actually again bringing enough in? So it's a devious, very complicated problem, which is more in techno-economical area even than pure technology.
It's also a regulation issue. I think in the European level there are already some regulations that require, for instance, cars to have modems. I think at some point it required them to have 3G modems, so now you have cars are no longer connected.
But you have to separate that. So I think this is also already a fact for the new cars, and it's inevitable. The cars will have an eSIM and a connectivity for the Telias or whoever else.
Yes.
That's what is happening. But car to road or car to car communication, that's a tenfold much more harder problem. But this kind of having a sensors and automatic giving a 112 call for emergency, that's no brainer.
Then I think when 5G location-based services are, let's say, in production, that probably opens new opportunities, especially underground in the mines. That's important. It's a really weighted feature that will be there.
Well, that or what is the bottleneck? Because I mean, I understood that 5G network, for instance, not yet some products they have those signals in place, they are not being used.
According to my understanding, that feature is not yet commercially available. That has been the discussion with Nokia, at least, that it's not that mature enough.
Yeah, I think it's a chipset, lack of chipset.
That tends to be many of the features, but they are very nice, and but there's no chipset on the modems.
There is also partly a problem that precision is not enough to differentiate it enough from GPS. It's a physical enough.
Yeah, but the mines are nice because you don't have a GPS anyway. So you anyway need some kind of new kind of solution.
Yeah. But for instance, compared Wi-Fi, 5G has a much better coverage there underground. Wi-Fi needs to have a line of sight always. So basically, you need to, when you're implementing the radios of 5G, you need to basically put it everywhere. Whereas the 5G enables the coverage much better. The signal goes in a let's say, better way there. I don't understand all the details for that, but that has been the case there underground. Yep, but that was the use case from the mining. So if we now continue and jump into the, let's say, findings, what we did. Basically, in order to build this industrial 5G solution, it's not only the connectivity, definitely not. You need to have, first of all, the sensors, and the sensors can be like drones or video cameras, etc. But you have to have, let's say, devices that are able to sense surroundings. Then it's the connectivity. And obviously 5G is the latest technology there for the mobile one. And then you need to have a data storage, place where the data can be stored. For instance, if you want to store the video data, there has to be a secure way of storing it and building this analytics on top of it. And now these three first ones, the sensor, connectivity, data storage, they're basically available. It's very standardized across industry. So you don't have any specific for that particular industry versus that particular one. So basically it's very, I would say, common across industry, so industry agnostic. But what to do with the data, that's where the value comes. Then comes the machine learning, AI, so analytics. Then the application, what kind of applications you need in order to utilize the data, and that is very industry specific. And then finally, if you want to make a new business out of it, or you want to utilize that in your production improvement, you need to probably have a standardized way of working. You need to have a service out of that. So those three latter ones, they are pretty, let's say, industry specific. They are very different in forest industry versus mining, or Kone is not able to utilize innovations what has been done in oil and gas. But what is common is the first three ones: sensors, connectivity, and data storage. And that really makes sense if you think about it from the helicopter perspective. That was one of the findings we had in this research. And this is now explaining these different, let's say, areas more in detail. And I would say the most attractive use case for the industry seems to be the video streaming. And when you are sending video signal, for instance, underground, it's the uplink capacity for the radio that is more important than the downlink. And traditionally, when we build networks and design networks, it's always downlink is the, let's say, the higher value. But in this industrial use cases, can be another way around. That's good to understand as well. And obviously, when we are talking about artificial intelligence, machine learning, and these kind of things, they are very much driven by the industry sector. There is dedicated use cases for that particular use, and the different automation system for constructions and the forest industry, for instance. But those 6 pillars are actually important. And what I didn't mention is that, as you can see, there is this, oh, it doesn't work. There is this lock between different building blocks. And the locks are obviously data security. So when you build this kind of system, you always need to make sure that there is some kind of assessed data security protocol and process applied. Because there's always a risk that the data goes to internet and somebody can have access on that. One of the learnings we had as well was that I tried to summarize in a, let's say, simplistic picture. that you have different kinds of applications. Not all applications are mission critical. Your users in Industry Park, they have regular, let's say, commercial applications they want to use. And then there might be very dedicated critical applications to manage, for instance, the pulp process. And if you want to use that mission critical applications, it's better to have a private cloud, better to have a private network in order to guarantee that the data is not going outside and nobody has any possibilities of manipulating the data. And that also enables that the latency is as low as possible because the computing takes place closer to the users. So that's like a private 5G network and a private cloud. And as I said in the beginning, 5G is much more than connectivity. So it's basically combining this connectivity and computing together. It's this cloud native approach. So basically you can distribute your computing in different places. And that's one of the biggest, let's say, value for the 5G standalone technology. Okay, then you might have industry-specific application you want to run on your private network. You don't want to run it from the public network, but you can use your industry public cloud, for instance, Azure or AWS cloud, where every, let's say, stakeholder who have some kind of role in your process, they have access to. So that means the industry-specific applications. Then if you go to the right and up corner, you might have very data sensitive, like I would assume, for instance, in hospitals or some kind of, let's say, very sensitive data that you are treating. You don't want to have any public cloud on that. But basically, you can run the connectivity on a commercial 5G network. And then the basic commercial applications, actually there are quite many of those in use. You can basically run from the cloud, public cloud and public network. That this brainstorming is still ongoing, but there is a clear, let's say, different need for different kinds of applications. That's my point. And how you build it, you have to be, let's say, clever. You don't want to put everybody in the same silo, but you want to have, let's say, as flexible as possible way of working. Then about the edge computing. In my view, edge computing is basically enabling virtual private cloud. So you can have a virtual private 5G network. So you can run your let's say capacity from the macro network, but it's dedicated for you, and it's dedicated so close that the latency will be low. And that's kind of edge computing and virtual private network. That is actually quite attractive concept at the moment. Many companies are looking into that kind of applications. Of course, there are many barriers, and we listed down the barriers with 5 companies, 5 industry sectors, and basically conclusion is presented here that top 5 barriers: technology, total cost of ownership, competencies, change complexity, data security and privacy. And then the industry sectors are marked as 1, 2, 3. They are not on purpose, they are not saying which industry, because we didn't want to share the data. But basically it means that when we started to prioritize then these together, so everybody had this one vote for these different barriers, and that was the end result. The competencies is actually the biggest barrier for implementation at the moment. And I fully understand that, because it means that you need to have a basic understanding on your industry process, but also understanding how you integrate not only IT, but the OT into the connectivity as well. So as we are in the industry area, most, let's say, critical systems are automation systems, and I would call it OT, and that has to work seamlessly together with the IT systems. And that knowledge, that competence is very hard to have in one single head. You need to have a team of experts who can do it. And therefore this competence is the biggest challenge, or biggest barrier, we call it. Change complexity, obviously, it's not any trivial thing. As we understand, there's lots of legacy, not only in the mining, but also in the forest industry and in the construction industry. You cannot go and just say, this is the new technology, start using it, but you have to understand how the legacy and new technology are working together, what kind of, let's say, processes there are. Then technology, obviously, that's one of the barriers, whether the technology is mature enough or whether the technology is able to integrate to different systems and so on. Total cost of ownership, in this research we were only focusing on the operational topics, so maybe this total cost of ownership is not saying the whole truth, but that wasn't top 3. It was important, but it wasn't top 3. And what was amazing was that this actually data security and privacy was ranked as the number 5. But then after discussing the voting and discussing with the people, they actually considered that when you are taking the 5G into use, it increases the data security and privacy. And that was the reason why they didn't consider that so relevant or big barrier. So that's about the summary of that. And then, as I said in the beginning, we have done a book. It will be published hopefully in December, in this winter or anyhow. And that will explain more thoroughly these different use cases in the mining with Sandvik, forest industry with Metsä Group, Telia energy things. Then there is the Neste refinery and drones, and then Kone lifts in the construction phase. So that's shortly my presentation. So any comments, questions? Yes, you.
Maybe a question related to the competencies.
Yes.
I was wondering if it's fair to interpret that also as a kind of uncertainty of what 5G brings as benefits. So if you don't understand what it brings, then why waste time in spending any time thinking about it? So is it more of how much? So let's say as a question, how much understanding affects that and understanding the benefits or lack of benefits, for example. So is it just the skills or kind of sales problem, if you will?
I think it's both, but I would assume that at least in these use cases when they were described and tested, the benefits were, let's say, centered around not only on the connectivity. No, that's not the point. The point was that how could you build more reliable process? For instance, in the mine, when comparing Wi-Fi and 5G, it wasn't that whether it's a better connection or not, but it was that it was more reliable. 5G clearly was more reliable, meaning that there were no stops or the latency was fluctuating in certain limits, whereas Wi-Fi was going up and down. So the stable process, the reliability, that was clear benefit. And then, as I mentioned, there are many use cases where video stream is in interest. So you have to collect different video sources and then make your analytics in your control center. So sending out the video stream with 5G is better because there is more capacity. I would say those are probably the two biggest ones. But obviously, I mean, competencies in order to understand what is possible of doing, clearly, that's a challenge, that's a barrier. And typically it's so that people who understand technology, they don't understand how the business works, and vice versa. The business people doesn't understand what the technology allows. So it means that you have to have like teams working together in order to understand the potential benefits and use cases. Yes.
A bit different question. A lot of things what you presented are related to organization of the network. I don't know, is Telia at the moment in 3GPP. What is your view of the future of 3GPP? Does it need new physical layer for 6G, or is it only now the applications and the moving forward? What is, especially if you think like the ORAN and stuff like that, what the operators have put together and
for the operators, I think it's pretty clear.
We don't want to invest again to the new technology. I mean, we have made again a big investment on the 5G. If we could utilize 5G technology as basis for 6G, that would make sense. I think all operators agree on that. So the capex and investment levels are driving that demand. But regarding overall the specification for the 6G, to be honest, I'm not so involved in that. So what kind of opportunities there will be? We are analyzing now how this virtual environments like metaverse, what kind of opportunities that open. But I cannot say yes yet what would it mean in terms of the 6G standardization. But I would say the general challenge in this industry is always that the operators are investing all the time to the new technology. And that's the reason why let's say during the last 10 years or so, the industry, including the vendors, including Nokia, Ericsson and Huawei. No, I don't say anything on Huawei now, but regarding the key vendors, they are not able to, let's say, scale up because it's always the investment. So if 6G standardization work starts with the fact that let's utilize the investment done in 5G, that's of course good for the operators.
But also, I think one of these bottlenecks is that the different releases, they have lots of features introduced already, 15, 16, and so I think this high accuracy interpositioning was in release 16 quite many years ago. But still we don't have hardware for that. So there's a kind of delay when we have these features that have already been standardized. And that is about how much business value of those releases or features there are.
Yeah.
And I think it's also a kind of challenge with the marketing department. You can see that the one that the Nokia slide from 6, 7 years ago, the one that actually was in the bottom right corner. So that actually shows all the possible features that 5G has or will have.
Yeah, exactly.
But we don't have those yet.
Yes.
So it's kind of marketing challenge also. There's a lot of hype going on and understanding that 5G solves a lot of problems or challenges.
But that's always so.
When you are entering the new technology, first there are lots of hypes. And that was the reason why I wanted to start with this illustration, because this shows that it's a long life cycle we are talking about. For instance, this GSM, 35 plus, even 40 years soon. Just imagine.
Just referring to this long life cycle, is this 6G really new technology, hardware technology? Or is it based on 5G, it's just the next release?
I'm not involved in the standardization, but you know.
Yeah, but my idea is that just one more marketing challenge. Yeah. So 6G is coming. Why to invest in 5G?
In 6G, there seems that there's no new good frequency bands available, and they haven't really used millimeter wave for 5G yet. So why go to the higher frequencies?
I mean, generally, I was going to say don't quote me to Karaportti, but you can. Yes, 6G is basically a marketing term.
Yeah.
It's simplified version is it doesn't mean anything at the moment.
Yeah.
It
It's
might
the next
mean
release.
someday, but
Is it release 22 or something like that? That is called 6G. I'm not
Yes.
sure about that, but
yes,
anyway,
and we
something
have to
like
remember that there are real innovation in 5G, but it's debatable also that if 5G is really a new generation or is it an advanced evolution of the LTE. In a sense that the jump from the 3G to LTE was huge. That was huge technology. I think why we are seeing that the 5G finally is a successful, that it's very much what Jari was saying, it's building upon the LTE. It's not requiring immediately a huge reinvestment in the network. I have one question. So it was very nice to hear that actually one of the drivers is uploading video. I do tend to believe it.
Okay.
But there's a one magical number in your slides. I think it's in the next slide. And it's always generating me this question. And I'm not blaming Telia because this is more from the vendors. But where is this mythical 1 millisecond latency need from? What is needing in a large scale? 1 millisecond end-to-end latency.
Yeah, I would say in the industries where we're discussing the latency, I think this 10 or 20 milliseconds is sufficient. You don't need to go into millisecond level. I agree on that.
That's very, very nice to hear again. That
Yeah.
industry, because I never have been able to find anyone saying that I really need it. It's more like 10 to 14 milliseconds depending.
And
Reliability, how many nines?
Yes.
yeah, but I would say that telecom is becoming more and more closer to the electricity type of or energy, so that you just have to have it as reliable as possible. And as I said earlier, that the fluctuation of latency is more important than the latency itself. If the latency goes up and down, you cannot rely on that. But if it's within the certain limits, okay, you know it, then you can design your processes around it. Yep. All right. Thank you. Thank you.